Hi, and welcome to a new episode of the Plumbers of Data Science podcast. Today is all about ETL. Extract, transform, load. Is ETL dead in data science? Is it still alive? Do people still use it? Yeah, I have selected some questions from you that I find interesting and that fit to this topic. If you're new here, please hit the like button and subscribe to the channel, and let me know in the comments if I'm doing something wrong or if I'm missing something. That would be great. Or if when you have some new questions, you can send me new questions either here in the comments or on Twitter using the hashtag plumbers of data science. Yeah, let's start. Before we begin, what's your take on the Tesla situation that Elon Musk lost his seat as lost his seat on the board as chairman of the board? I first thought, okay, they Steve Jobs'd him. I mean, not dead, obviously, thrown him out of his own company because of a tweet. The stock was tumbling, I think, 19% or something. Crazy. What's your take on that? Okay, so first question from Vinay. Data warehouse and data lakes, what's the difference? So the difference between a data warehouse and a data lake is, when you think about the data warehouse, the data warehouse is something very well defined, very specialized. It's like when you're doing SQL databases, you create structures for each and everything, and then you insert the data into this very well-defined structure that is a data warehouse. And when you think about more a data lake is more a loose storage of data, very different. You can store very different formats. You can store different sizes of data. And it's more a versatile data store that usually does not need, where the structure of the data that you're storing usually does not need to be defined before the data is inserted. So this is why the data warehouse is so good and so easy to be accessed, because it is a well-defined structure and a well-defined system, and this makes it harder for data scientists or for data science in general when you work with big data structures and you work with, for instance, a data lake, that you need some information how the data is placed and how the data is structured, so you can access it. So the data lake is something different than a data warehouse. Is ETL still practiced, or pre-processing and data cleansing in data science took over? That totally depends. I would say a lot of people are still doing ETL on data lakes or on big data systems. It all depends on what kind of data, how you process the data. Let's say you're storing a lot of data in a big data, in a Hadoop system, a Hadoop-based data lake, and you're doing an analysis of a one-time analysis of because you want to create a model and test something out. Usually you're not going to go the way that you are that you're creating a whole pipeline for doing it, and many people are just extracting the data. It's like, say, it's a few gigabyte, just extract it, and then do the whole data processing and analytics as a batch, and then load the results back into the system. So it's I'd say this is still very common. A lot of people do it, but it's not the right way to automate stuff. So if you're on a data lake and you have the right structure, what you want to do is you want to work in parallel over everything. So data is stored in parallel. The processing is done in parallel, and then the answers are shipped basically to a UI or made accessible for a UI that can everything, so that the whole pipeline is in parallel, and you can use this whole infrastructure and this powerful infrastructure of such a tool. Because at some point you want to you need to do something different than ETL when the size of the data that needs to be processed gets too big. Let's say in the first example I just gave is you have only a few gigabytes and you want to make an analysis on a few gigabytes. Then ETL is okay. We can do ETL, no problem, because you can extract the data and transfer it to your instance where you're running the analytics on. So this is not a problem. But when you think about you want to run something on a terabyte of data, 2 terabytes, 10 terabytes of data, you want to make a quick analysis, and then that's no longer possible. That's over, and you need something else than ETL, and then you need some tool for parallel processing, like Spark. Yeah, I think you're a bit on the wrong track here with is pre-processing and data cleansing taking over ETL. That has basically nothing to do with ETL, because pre-processing and data cleansing is a way of processing the data. It has nothing to do with parallel processing or ETL or in-memory processing. That's basically another step. That means you already have the data, and with ETL you are getting the right data that you later cleanse or pre-process. And you can do the same thing with parallel processing in Spark. Okay, next one from Said here. What would replace ETL in big data engineering? Okay, first of all, it's always funny when you add the buzzwords together. So it's not only data engineering, it's big data engineering. So I find this very funny. It's big data engineering, analytics, machine learning. Nevertheless, Said, it's not that it's not getting replaced here. First of all, if, as I said just now, if you can work with ETL and ETL works for you, if you have small data sets, if you have a huge store and you're only taking small chunks, here, doesn't matter. You can do an ETL job from a key value store. That's totally possible, and many people are doing it. Especially if you're developing algorithms or something. But what replaces this are tools like Spark, where you're basically sitting on the data, because what is usually happening is that you're processing a lot of data, and ETL does no longer work because of selecting all the data and then shipping it out to a analytics instance. So what is going to happen is that you have a storage layer that is, for instance, HDFS. When you're working with HDFS, data is stored on the on many servers. So let's say you have a huge data set, and that data set then is splitted into blocks, and each block is distributed over the network of servers in the cluster, and also multiple times. And so you have your data is stored in a distributed way. And when the data is stored in a distributed way, you need a way to access it the same way, in distributed manner. And this is usually how Spark is, or this is how Spark is working. What you're doing usually is you're running Spark workers on top of your data storage nodes. And this way Spark can figure out which data is lying on which servers, and then the workers basically sit on top of the data, or sit on the exact machine where the data is stored. So you don't need to send data out over the network to a analytics machine, or transfer data. The Spark worker has direct access to the data stored on the node, and it does not need to transmit data over the network initially. Of course, it depends on what analytics you are doing, and yeah. So then, because then it will need to be transmitted. Some chunks of data need to be transmitted over the network, even in Spark. But I think those things are replacing ETL for huge data sets. Yeah. It's the same way with MapReduce previously. Vivian asks, could you do one on how to become a data engineer? Can you also do one on data warehousing? I would say I'm not the absolute specialist on data warehousing. There are a lot of other guys who can do on data warehousing. But in general, when I'm becoming a data engineer, I have something on my Facebook page. I've started to collect the things that I think are needed on some things that are needed to do data engineering, to become a data engineer. And I started collecting those stuff. And initially, what I plan to do is through the podcast here to actually add more and more to this node, and make basically a document where everything is collected that you need to become a good data engineer, or that you need to look at to figure out data engineering. I'm having it here. Let me just share my screen. It's a node. This one. Everything you need to know to become a data engineer. So first of all, if you haven't found my page at Andreas K from me, and there is a node called Everything You Need to Know to Become a Data Engineer. And in this node, I've selected a few stuff, and I'm going to add more and more to this. As I said, usually I try to do more through the podcast, but I'm not 100% sure how to I haven't figured out 100% how to efficiently post into this. So there I have a selection of things you need to look at, like SQL or Spark, or how to ingest data with APIs and JSON format, Docker, cloud infrastructure, computer science basics like networking and security and so on. So I think this is a good starting point for you. It's not a document that gives you all the answers. It's not that it's not meant to do this. It's meant to give you a short overview of things that you should look into and that you should Google and find out. But I'm going to add to this as well in the future. So follow my Facebook page to stay updated on that note and updated on the stuff I'm posting. Okay, that's for Vivian. So quick reminder, if you like this video and the answers I just gave, please hit the subscribe button and hit the like button to let others know that this is a very useful video. I'm planning to do this more often now. I'm planning to do this regularly, possibly every day. So let's continue with it. Okay, Ibrahim asks, how does one get experience with building data pipelines, ETL, and other data engineering principles while at home? It's actually not that super hard. It depends on exactly what you're trying to achieve and what are you trying to get into. I have one video online that helps you set up a Kafka in 3 minutes, I think. And there's also a way to install Spark over a Docker container. And so it's very simple, very, very cheap. And you can start with that. You can start then posting stuff to Kafka. You can then start quickly analyzing stuff from the Kafka stream, and let's say put it back into Kafka. This is totally possible. It's not super hard. One other thing is that you can run an analysis, or you can start coding Spark with Zeppelin. Let me just share my screen here. You can start with Zeppelin, where you can just put some data somewhere, and then you can write code either in Scala or in Python, or you can you can do that and then make it in some put basically the data then via your code into a data frame, and then you can visualize it with Spark SQL and work with it with Spark SQL. And it's super simple. They have a Docker image, using the official Docker image, and you can start super quickly with that by using Docker. I can make a video for that if you like, so yeah. Tell me in the comments if you would like me to make a video about how to use that image and get started coding with Spark through that image. Yeah, and this is the way to go. Don't need a lot. You can start very simple coding with those Kafka and with Spark at home. Write a Python producer for Kafka. Feed in generated random data and work with the data. Start by doing some averages over a certain amount of time, feeding that back to Kafka or into a SQL database. Yeah, this is the way to go. Getting hands-on experience, Ibrahim, is most important, and also document it, put it online, share it. If you share this, if you're making a documentation out of your experience and you're with your code, let's say on GitHub, share it with me. I will post that on my LinkedIn and other social media. Don't know where you're going to share it with me. Yeah, and build a reputation, build a bag of tools that you or skills with that you can then show some employers and find new jobs. Akif asks, which approach is better for real-time analytics? Should one offload data on relational database management systems, RDBMS, for instance, or use HDFS layer? This is actually, I think you're a bit mistaken here, because if you want to do real-time analytics, real-time analytics is more or less before the storage layer. It's you get the data, you process the data, and then you put it into storage for real-time analytics. You're not going to get the data, store it, then extract it and analyze it and then store it again. So it's a way, how I described many times, is you have an API, you get the data through an API, feed it into some streaming system like a message queue, and then feed it into an analytics tool like Spark. You could also do this with other tools like Flink and Storm. Doesn't matter. You're not focused on or limited to Spark. You can also do it with Lambda functions on AWS and with a Kinesis and Lambda functions and an API and so on. So real-time analytics has less to do with actual storage, but more with the processing in front of it. And so a good way is to use the processing. So then it doesn't really matter with HDFS layer or data or relational database. That's more in terms of storage, but real time is before the storage. Everything in real time, that real time in quotes, that's working before the storage. Okay, last question for today, because it's already about 7 a.m. and I need to get ready for work before the children wake up. I needed to make some cuts here and there because I have the baby phone here with me, and our oldest is waking up slowly. Is there a point learning Apache Storm when Apache Spark is making so many noises? That's a bonus question, let's say, for streaming. So I think right now you're seeing where the ETL questions are going and where the scene is heading. Storm is it really depends on what actually you are doing, and what your goal is. Storm is very good for processing real-time data. So if you want to have a super fast processing, and the data is coming in and is immediately processed, and it's one time fed through the analytics and through the processing, Storm is super good, because Spark also has real-time processing, but Spark is doing micro batches. So, for instance, Spark is creating once a second a micro batch and then analyzing that micro batch. And as far as I understood it with Storm, it's a bit different. Storm is more focused because it's coming from Twitter, and a tweet needs to be processed immediately when it comes in, and so Storm is even more real-time focused than Spark. Spark is more, let's say, limited to second real-time in seconds, and not faster for processing incoming data. And I think Storm is a good choice here. Generally, it really doesn't matter. It matters more into what are you trying to achieve. What is it that you need? What is it that you're trying to achieve? And figuring out the actual tool. And Storm is a good tool. I would actually also look into Flink. Yeah, but Spark has. I really agree, Shandan, that Spark has a huge community, and the Spark development it's crazy. You cannot keep up with the Spark development. It's so fast, and every time they add new things, and Spark is very strong with the developer community. And also, if you have questions or problems, you most likely get them answered, because the Spark community is so huge. Yeah, that's a huge upside. But if you're needing a lower delay than a second-wise processing, then I would say look into other tools like Storm and Flink. Yeah. All right. That's it for today. I hope you had fun. If you have some more questions, let me know. I love to answer your questions. Send them to me on Twitter, #Plumbers of Data Science, on LinkedIn, on Facebook. Join my Facebook page, and let's stay in touch. Hit the like button on this video to let people know that this has some really good information about data science, data engineering, and especially on ETL stuff. And then, let's meet tomorrow. Bye-bye.